This is the lab lecture for the procedure portion of the lab in Gen Chem 2, the preparation and analysis of aspirin. So we're making aspirin. We're trying to make aspirin anyway. And this is your glimpse into organic chemistry lab. Now I say it's a glimpse because most of the glassware that you're working with in this lab is still the glassware for Gen Chem and analytical chemistry. Organic chemists have kind of their own set of glassware, and you don't get to use that until you take organic chemistry lab. And at least at St. Charles Community College, you don't get to take organic chemistry lab until after you've taken one semester of organic chemistry. So organic chemistry 1 is lecture only. Organic chemistry 2 goes with the lab. So you got to learn some organic chemistry before we let you do it in the lab. So this is, like I said, a glimpse of that. And as someone who, I'm a chemist, obviously, or else I wouldn't teach chemistry, but I'm an analytical chemist, which is almost the exact opposite of an organic chemist, which means I like numbers and I like to be exact or as certain as possible. Sig figs are my thing. So organic chemists in the lab, what you'll kind of find out with this lab anyway. So you're going to start with a white solid. You're going to do a lot of stuff to it. And at the end, you're going to have a white solid. It's going to be a different white solid, and you just kind of like throw it around. Hey, put it in here. Then scrape it over to there. Oh, it's fine. Just keep going. So it's just a different kind of lab setup. Okay, so for this lab, we're going to be taking salicylic acid as our starting material, mixing it with some stuff, and hopefully creating aspirin, which is acetylsalicylic acid. So that's one part of the lab. Make the aspirin. Okay, now, again, we start with a white solid. We end with a white solid. Looking at it with your eyeballs does not tell you whether or not you were successful in taking the salicylic acid and turning it into aspirin. So we're going to do two different types of tests. And this is a really common thing for organic chemists because, again, you can't tell. Sometimes when things are real exciting, you turn a clear, colorless liquid into a maybe slightly yellow clear liquid, and that slightly yellow is probably an impurity and not supposed to be there anyway. So we're sticking in the solid world for this lab, but sometimes chemists or organic chemists turn liquids into other liquids. So we're going to do two tests because you always have to do tests at the end of these because you cannot see visibly whether or not you were successful. So we're going to do the phenol test, which is like a color test. It's going to tell us the presence or absence of this functional group, a phenol or phenol. So we're going to test the starting material, salicylic acid. We're going to test the product that we made, and then we're going to test pure aspirin that we purchased and we know is aspirin. And based on how the salicylic acid starting material and the pure aspirin behave, we'll be able to look at what happens to the thing that you made and get some sort of information from that on how successful you were. Now, even that doesn't necessarily guarantee anything. So we do multiple tests. So we're also going to do thin layer chromatography, which is something that you did in the very first lab, the chromatography lab, that we're repeating again. And we're once again going to be comparing the three things, the starting material, acetylsalicylic acid, the starting material, salicylic acid, pure aspirin, acetylsalicylic acid, and then the thing that you made. And then based on that, get some idea about what's happening. So 3-part lab, but with organic chemistry labs, it's not so much like it is with a lot of the other labs that we've done, which is like you do part A first. And part A is, do this, I accomplished it, check. And then part B, we do it second. And then we do this and we accomplish that, which is a different thing that we did in part A, check. There's a lot of waiting around in organic chemistry labs. These reactions, the kinetics, are not always very quick, which means these reactions are slow. So while you're waiting for one thing to happen, you need to be working on the next thing. So the way this lab was written was more in the order in which you need to do it, not so much broken into the 3 separate things that we're doing: making aspirin, doing the phenol test, and then doing the TLC. Okay, so just know that in advance. So when you're recording your data, you might be flipping between some pages because the data is set up in those 3 ways. So it's easier for you to answer questions about it. So starting off, when we heat things in organic chemistry, we don't get to put them directly on the hot plate because most organic chemicals are flammable. So we don't want them super close to the heat source. So instead we make a water bath and we put the water in the container on the hot plate, and then we submerge our solution that we need to warm into that water bath, kind of giving it that buffer where it's not directly touching the heat source. So we're going to be starting by making a water bath using what's called a recrystallization dish. This is a piece of organic chemistry glassware. So it's just a flat bottomed round thing. We're just going to fill it about halfway up with water. Tap water is fine. Its entire purpose is just to get warm so that way we can dip other things in it. Okay, so you're going to start heating that. Now we don't want it to boil, so we're not boiling it. It needs to be 80 to 90 degrees Celsius. So hot, but not boiling. Okay, so while you get your water in there and get it starting to heat, and again, you can just use your thermometer to periodically check the temperature to see what's going on. We're going to start our reaction. So we're going to start our reaction, and it's going to happen inside of a 125 milliliter Erlenmeyer flask. So this is smaller than the Erlenmeyer flasks you used to do your acid-base titration earlier in the semester. So you're going to measure out about 3 grams of this starting material, salicylic acid, which is a white solid. You're just going to measure it using whey paper. Now it says about 3 grams, but you do need to accurately record the volume in your lab. It's going to be important for us because we're going to be calculating like the theoretical yield from things like that. So about 3 grams. And then you'll use your whey paper to transfer it into your Erlenmeyer flask. Now there's really not a way for you to rinse the whey paper. We will be adding other chemicals, but very small volumes of those chemicals. So again, salicylic acid, it's a solid, just going to kind of be at the bottom. Next, we need to mix acetic anhydride to this. And I forgot, we have to wear latex gloves for this lab. Latex gloves protect us best against organic chemicals. So if you have a latex allergy, you're going to put on 2 pair of nitrile gloves, then a pair of latex gloves. If you do not have a latex allergy, just put on the latex gloves, just 1 pair of latex gloves. You will be asked to change your gloves periodically throughout the procedure. If you have a latex allergy and you have on 3 pairs of gloves, you're only changing the outside pair. The other 2 should be fine. Okay, so backtracking. We put 3 grams of solid in here. We needed to add one of the reactants, which is acetic anhydride. Acetic anhydride is a liquid. You're going to be measuring out 6 milliliters of it using a 10 milliliter graduated cylinder. Acetic anhydride is harmful. You will read the safety data sheets and answer the safety questions before you're allowed to do this lab, so you will know that. So we're going to make sure we work with this under a fume hood or snorkels, and we're just careful with it. We have our gloves on. Okay, so measuring out 6 milliliters, and then you'll transfer that on top of the salicylic acid. And then next we need to add sulfuric acid. Now, it just says in the procedure concentrated sulfuric acid. 18 molar sulfuric acid. This stuff can burn you. This stuff is definitely hazardous. So you're only adding 5 drops of this. The bottle of concentrated sulfuric acid will be sitting there with a dropper bottle or dropper plastic disposable pipette right next to it. You're not going to pour the concentrated acid into another container. All you're going to do is use that disposable pipette to dip it into the solution, fill it up, bring it out, and squeeze 5 drops into your reaction mixture, and then put it back. If you accidentally get 6 drops, that's okay. So a little bit more is fine, but we're trying to get, 5 drops. And be very careful not to get this on your skin. It will burn. It will be harmful. It will not feel good. We'll have to, rinse your skin in the sink and potentially seek medical assistance afterwards. So just be very careful. That's why you're not pouring it. You're just going to drop, 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 and then we're moving on. So at this point, we have a lot of solid and tiny bits of liquid. Okay, so it's not like it's full at this point or anything. Okay, so what we need to do is we'll let this react. So we're going to use a stir bar, same kind of stir bars we've used in the past. We're going to drop it in there. And then hopefully at this point, your water bath is ready to go. So we want to submerge our Erlenmeyer flask in the water bath, but if we just try to put it in now, it would like float around and bob around and like knock over. So we need to use a clamp to hold it in place. So you're gonna start with a knuckle, which just has 2 things that connect here, and I'm going to attach it to my post. I'm gonna scoot you over. And then I'm gonna get a finger clamp, call it that because it looks like a thumb and 2 fingers to me, and attach it to the other side of the, further out, there we go, the knuckle clamp. And then we're going to be using the finger clamp to tighten and hold the Erlenmeyer flask in place. Then you can lower it down so it's submerged in the water bath. You have to make sure that the chemical that's at the bottom of the Erlenmeyer flask is completely submerged in the water bath, but the whole flask does not have to be, just so that way all the chemicals are. Now, we're also going to, so the heat will be on the hot plate. You're also going to turn on the stir function because we need that stir bar to mix, but the stir bar is like floating up here, the stir function's down there. So what's going to happen is the stir bar is not going to be nice and fluid and smooth as it normally is. It's going to kind of jump, wiggle, stop, think about its life. Wiggle a little bit more, jump, think, stop. So as long as it's moving at all, even if there are pauses, it's agitating liquid, that's all we need. So it's not going to be spin, 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 nice, happy, perfect. There might be some clinking because it's going to run against the glass. Again, there's a gap between the magnets, so it's not going to be perfect. So that is going to need to mix, stir, and heat for about 20 minutes. So you need to periodically check on the water bath to make sure it's still in the 80 to 90 degrees Celsius range. But you're going to let that stir and mix, just checking on it. While that happens, you're not going to sit here and stare at it. You got to move on and start working on other things so that way you can eventually finish this lab. So what we're going to do is start the phenol, the color test. Okay, so we're going to need some test tubes. So you're going to get a test tube, an empty test tube, and you're going to get the bottle of pure aspirin, which will be labeled, and you're just going to, it says transfer a few crystals. So that means like a tiny, tiny bit. Okay, just a tiny, tiny bit of it, and put it in the test tube. Okay, with a nice clean scupula or spatula. And then it says to add 5 milliliters of deionized water. Well, you can just use your squirt bottle for this and just, squirt in a decent amount of water. You can also measure out the 5 milliliters, but it's really okay. And then you're going to add a drop of a 1% iron 3 chloride solution. So that's the chemical that's going to change color depending on the presence or absence of this phenol functional group. So you're also, I guess, when you do that, you're also going to want to stir it with a glass stir rod to get it, some of that solid to dissolve. And so then you're going to write down what you see, your observation. So it's going to be like a color. Did it turn green? Then write down turned green. It's just an observation. Okay, so you're going to do that for aspirin. Then you're going to do it for salicylic acid. So aspirin's the acetyl salicylic acid. Salicylic acid is the stuff that you just put into the Erlenmeyer flask to start your reaction. So you're going to take a second test tube that's nice and clean, put in a few crystals, put in some water, stir it up real good, add 1 drop of the FeCl3, and write down what happens. Now these two things should have different things happen. So maybe they change colors, but they're different colors. Or maybe one doesn't change color and one does. But if they both have the exact same thing happen, then you had some contaminants between those and you should redo both of them. Okay. So you're going to record that in the phenol test thing, the color of pure salicylic acid plus FeCl3 and the color of pure aspirin plus FeCl3. The third color test, it's the color of product, which is what we're calling the thing you made. You haven't finished making it yet, so that'll come later. That's actually the last thing you're going to do is the color test of the product. Okay. So once it's been 20 minutes, so you're doing that, and then while that's happening, that's mixing. You're able to remove the Erlenmeyer flask from the water bath. You can turn off the hot plate. Okay. And then you're going to remove it from the clamp and just let it sit to slowly cool to room temperature. Okay. So it says in the lab, and then so allow it to cool to room temperature so it's no longer warm anymore. It's just like the color or the temperature of your hands. And then you're going to put it in an ice bath. So do not go directly from warm water bath to ice bath. That's a dramatic temperature change. Things can break. Plus, you won't get as good of results. So it needs to slowly cool first before it goes into the ice bath. And it says squiggly line 2 minutes. So it's only going to be in the ice bath for about 2 minutes. And then you're going to add 40 milliliters, which you can measure using a graduated cylinder, okay, of deionized water into the Erlenmeyer flask. So I guess before I say this, before you add the water, like once it did its 20-minute thing and then you let it cool and then you let it cool, when you first take it out of the ice bath, it should be a clear, colorless liquid. You don't see solid anymore. It looks like it's just like all dissolved, okay? And that's great, but we're trying to make aspirin, and aspirin's a solid. So what happens is this is a saturated or a supersaturated solution where things are dissolved because it's at a high temperature. So we're trying to make the aspirin precipitate, become a solid, so we can separate it. So we're going to add the 40 milliliters of the deionized water and then swirl it. And then you're going to put it in the ice bath. So somewhere in this, 2 minutes in the ice bath, 40 milliliters of water, 10 minutes in the ice bath, hopefully you see white solid crystals starting to appear. And it's going to depend on how well things went on how many crystals there were. But at the end of those 10 minutes, hopefully you've got visible solid in there. Now, not all of it will be solid. There'll still be some liquid, but some visible solid. Okay. So we're cooling it down, you know, to make it so that way it doesn't dissolve in the solution anymore. Okay. So at this point, you want to take a beaker and put a little bit of deionized water. The lab says 80 milliliters. I would overestimate on that and put like 200 milliliters into a beaker and then set it in the ice bath too. So this buddy's sitting in the ice bath and you're going to have a beaker sitting in the ice bath. Later in the lab, we need ice cold water. We're just starting to make our ice cold water, which is just cooling down the water. Okay. So there's two things sharing the ice bath. While it's doing its 10 minutes of cooling, we're going to get set up for the next step. And the next step is for us to filter out the solid aspirin, hopefully aspirin, but the solid product from the liquid, because we're trying to figure out not just did I make product, but how much product did I make. Okay, so we're going to filter it using what's called vacuum filtration. This is a technique used in organic chemistry labs, so this is an exciting thing. So on your lab bench, you will have some outlets. The ones that are yellow that say VAC on them are vacuum. Okay, we're going to be using that. So you're going to get a thick walled piece of tubing. So thick walled, like you can see that there's a lot of rubber between the inside hole and the outside. So it's like thick. And you're going to put one end onto the vacuum. Okay. Then you're going to get a 250, I believe it's 250. I hope I grabbed the right one. Or is it 125? Nope, 125. I lied. A 125 milliliter filter flask. Filter flasks look like Erlenmeyer flasks with an arm. Okay, so that's the difference. That's the filter flask, okay? And it says 125 on it. Then you are going to use the clamp. I would just say use the same clamp that you used earlier to clamp that filter flask, like attach it in place. And we want to lower it so it's sitting on the lab bench. But what happens is we don't want it to fall over. So we're clamping it in place so it's nice and sturdy. Okay. Then you need to get what's called a Buchner funnel. Buchner funnel is this piece of ceramic. I don't know how well you can see it. It has little holes in it. And then there's this rubber adapter. And so it's used to do the filtering. So that fits nice and securely on top of the filter flask. Now, I'm not going to put it on there yet necessarily because I'm not done connecting things, but that's where it's going to go. You're also going to need a small piece of filter paper that's the perfect circle size to fit on that Buchner funnel, because without that filter paper, there's holes. So the solid and the liquid would just go straight down it. Okay. So before we attach this to the filter flask, I'm going to take the other end of the hose. So one end is attached to the vacuum. The other end is going to be attached to the little arm on the filter flask. Okay, so that can make things a little unsteady. So don't put the Buchner funnel on here until you've done that, because otherwise things can kind of wiggle and then it falls off and breaks. Okay, so how this works is when we're ready, we will turn on the vacuum, and then that's going to, any liquid that's in here is going to get pulled down into the filter flask. So we're going to start by just spraying some deionized water on it, because what I want to do here is wet the filter paper so it sticks, so no solid can get underneath it. So when you're ready, you just turn the vacuum 90 degrees. And I don't know if you can hear the little bits of sound. Okay, so when you're ready to shut off the vacuum, so like at this point, it's pulled the liquid down, there's nothing else to do. We have a two-step process. First, we're going to remove the hose from the valve, and then we're going to shut off the valve. That seems silly. What can happen is if you don't take the hose off, we can have some backlash things. What happens is the liquid could get pulled into the tubing that would go into the vacuum. The vacuum there's a vacuum pump on the end of this that would just destroy it. Okay, so when you turn it off, you have to take the tubing off and then the valve. When you start it, you can, the tubing is on and then you turn the handle. Okay, so hopefully at this point you've got this all set up and it's been the 10 minutes of it sitting in the ice bath. So then you've got solid in here, right? This has got your aspirin solid in it. So what we're going to do is filter this. We need to pour this into here so the aspirin stays on top of the filter paper and the liquid goes down to the bottom. So you will then turn on this again, okay? And then you will pour whatever you can. Now be careful with the stir bar. Like when the stir bar comes out, you're going to want to get that out of there. But you're going to need to rinse that with that nice cold ice water that you had before. Rinse it to get all the solid crystals off, okay? And then once, it's rinse, what happens is there's still going to be solid in here. So you're going to shut it off. Okay. And then what we're going to do is take some more of that ice cold water, pour it in the Erlenmeyer flask, swirl it, pour it out into here, trying to get all the solid from there. Okay. And actually, I guess you didn't have to stop it at that point. We're trying to get all the solid in there. Okay. Once we get all the solid transferred, or as much as we can, where this is completely clean, there's nothing left in that Erlenmeyer flask. That's when we will shut off the vacuum. Okay. And we're going to add 10 milliliters of the ice cold water. So the water that had been set in the beaker. Pour a little bit in there. Then you're going to grab your glass stir rod and gently, carefully, you're going to agitate it. What we're trying to do is use that ice cold water to rinse the outsides of all these aspirin crystals. We want to get rid of any impurities or any other chemicals that are stuck. So we poured the water in. It's not vacuuming. It's not filtering right now. And then we're just using our glass stir rod to mix it up to make sure the water touches the outside of the crystals. What you don't want to do is be real aggressive about this, because remember there's a piece of filter paper at the bottom, and if you're super angry and it's like, and then you rip your filter paper and then all the aspirin goes down, and that's sad. Okay. So you're going to do that. And then it says to reconnect everything. Turn on the vacuum again, let the ice cold water go down, and then we're going to do it one more time. We'll shut off the vacuum by taking off the hose, turning off the valve, adding a little bit more water, mixy, 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 put it back on, and then filter it. Okay. So at that point, you're going to leave the vacuum filter on for 5 minutes. We're trying to dry this as much as possible. We want to get all the water and other chemicals off of it. So we're letting the vacuum just pull liquid out for 5 minutes. So while you're doing that, so the 5 minutes, what you want to do is get yourself, why can't I think of the name of this? Watch glass. It says a medium to large watch glass. And you want to go over to the balance. So while the 5 minutes is happening, you're going to go measure the mass of this while it's empty. And you're going to write your initials on it. When it's been its 5 minutes and you turn off the vacuum, you're going to then be trying to transfer as much as you can of the solid from the Buchner funnel onto the watch glass. What we're going to do is this is going to go in the oven so it can dry even more. Okay, so you're going to scrape as much as you can. Now, you're not going to be able to get all of it. Again, this is where organic chemists and I disagree. It's like, why would you leave it there? But that's what we're going to do. And actually, we do have a use for this. So we do need to leave at least a little bit of solid behind. But you're going to transfer it all into here, and then it needs to go in the oven. We're not measuring the mass of it yet. We don't measure the mass of it until after it's dry. Okay, so we take the wet solid, put it on here, where I already did measure the mass of this when it was empty. And I put it in the oven, and it's going to dry for 30 minutes. So you'll have to keep track of time so you know when it's been 30 minutes. Okay. So while that's happening, there's one test we haven't even started yet, which is the thin layer chromatography. Okay, the TLC. So let's talk about how to set that up. I'm going to move this stuff out of the way. Okay. Oops, Buchner funnel. Stop it. Good news is we did TLC back in the chromatography lab. So you've done this before. So as we go through this, I'm hoping it's familiar. So you're going to need a 600 milliliter beaker, a piece of filter paper, and a different watch glass. Not the watch glass that's in the oven, but another one. Sorry. So what we're going to do, this is our developing chamber. This is where the TLC is going to happen. We're going to take a piece of filter paper and a pair of scissors, and we're going to cut a flat edge along the filter paper. Okay. Our goal is to have that flat edge at the bottom of the beaker, so where the filter paper does not stick up, but it's the perfect height. Well, I did not accomplish my goal, so I'm going to cut some more off until it's just the right height. There we go. So it fits perfectly inside of this. I don't know how well you can see. Okay, and so then the watch glass, its job is to be the lid. So that's our developing chamber. So once we get the filter paper cut, you're going to need to add 20 milliliters of a 65 to 30 to 5% mixture of hexanes, ethyl acetate, and acetic acid. These are actually the same chemicals that we used in our developing chamber for our mobile phase, or solvent, however the word we want to use for this, as we did in the chromatography lab, but it's different concentrations. It was a different mixture. Okay, so you're going to pour 20 milliliters using a graduated cylinder into here, and then you're going to want to swirl it around We want to get that filter paper completely wet, but swirling it, no matter how well you swirl, it's not going to get it all the way wet. So what needs to happen is it just needs to sit, and so the water or the liquid can wick up the top. So write your initials on it and make sure it's under some sort of fume hood or snorkel, because it's going to be stinky, like really strong vinegar, and just let it sit. Okay, so that's going to be sitting. So next we need to start preparing our chemicals that we're going to test. So you will have already used 2 test tubes to do a color test. What we're going to need is we're going to need 3 more test tubes at this point, okay? And you're going to go back and get some of that pure aspirin and that pure salicylic acid. So using a piece of whey paper, you're going to measure out about 0.01 grams of salicylic acid using a piece of whey paper, and then pouring as much of that as you can into the test tube. There is nowhere to record the mass of this. The reason why I'm having you measure it out is because we need to add enough to make this work, but not too much that it won't dissolve. So that's why we have to measure it. And so you'll label this with salicylic acid. I would say like SA. Then you're going to take your aspirin, and measure out 0.01 grams of that on another piece of whey paper and pour that into the aspirin thing, like A for aspirin. And then you're going to take your product, which is going to be whatever leftover junk is still in here. Hopefully 0.01 grams of it are still in there. And you're going to measure out the mass of that and then pour it into the 3rd test tube. Let's say you couldn't get 0.01 grams out of this. Then you're going to have to go in the oven and steal a little bit of your solid that's drying until you have 0.01 grams. Okay, put it into a test tube. Okay, so now you have 3 test tubes, salicylic acid, aspirin, and the thing that you made. So what we need to do now is to add 2 milliliters of methanol to each of them. So using a small graduated cylinder, you're going to measure out 2 milliliters of methanol, pour it, pour it, pour it. Then we want to mix it or vortex it. So our vortexer is over here, until all 3 solids completely dissolve. So they need to be completely gone. Those are the 3 chemicals that we're testing for our thin layer chromatography. To do our thin layer chromatography, we need a TLC plate. TLC plates are glass on one side and have a solid coating sprayed on them on the other. The solid coating is the side that we're using, and it's going to serve as the stationary phase. So using a pencil, we have to get this prepared. You're going to go 1 centimeter from the bottom, draw a straight line over. Then we need to have 3 evenly spaced tick marks that you're going to label underneath them, like SA for salicylic acid, A for aspirin, and P for product. Okay, so it's all ready to go. And again, it has to be in pencil. Now, to transfer the chemical to this, we're going to be using micropipettes, which are just really tiny pieces of glass that let little bits of liquid fall up them. So you're going to take a micropipette, dip it into salicylic acid. Okay, so a little bit sticks inside of it. And then you're going to go to the hash mark for this that you have labeled for the salicylic acid and do a really quick press and release. So we want to make a dot, but we want it to be a very tiny dot. We don't want it to get very wide. The longer you hold this down, the wider it gets. Now, we're going to do that, but we also want our spots to be dark enough for this to work, like for there to be enough chemical. So once it's dried, you're just going to take it and you're going to do that again, a second time, maybe a 3rd time. You don't want the dot to get any wider. We just want to add more layers of chemical so it's more concentrated. Once you're done with that micropipette, you're going to get a second one. Now do it for the aspirin, dot, dot, dot. Now do it for your product, dot, dot, dot. So you've got 3 spots. Now you will not be able to see the spots at all. So in order to see the spots, you will have to use a UV light where, I don't know if you can really see the green. This white coating turns green when treated with this UV light. Your spots will not be green, they will just be dark. Okay, so that's how you can check how big your spots actually are. Make sure that they're dark enough and big enough to actually let this run. Once they're on there and they're dry, you're going to get your developing chamber, which at this point has hopefully, the filter paper is wet. You're going to put your TLC plate into the beaker with the filter paper, putting on the lid, and we're going to let the mobile phase move up the TLC plate until it gets 1 centimeter from the top. Once it's 1 centimeter from the top, you will use a pair of tweezers to remove them. Set it on a paper towel, and then take your pencil and trace the motion, or how far the solvent, the mobile phase went. So you're just going to trace it. Okay. So at that point, we're just letting it dry. Then you will use your UV lamp to again shine on there and look for any spots. So any spots that you see that are not green, circle them with your pencil. Okay. In order to translate this into something meaningful, you also need to, while you're looking at the spots, keep an eye on what color the spots are. So like when they're treated with the light, are they a different color? So the white stuff is green, right? Like the white stuff. Maybe the spots, maybe one of them just looks, like black, like there's no color. Maybe one of them is, dark, but has a little bit of a purple tinge or something. Look for those colors. You're going to record that as well. Once you've circled everything and you took note of what they look like under the UV light, you're going to grab a ruler and you're going to be measuring the distance from the starting line, which was the line that you drew, to the middle of each spot. And then also one time from the starting line to the solvent line, which is the top line from where, not the very top of the thing, but where you drew your line when you took it out. Okay, so you'll record those in millimeters, which means, again, read the ruler correctly, go to the correct, write down everything you know for sure, and then one place past that, and then you'll be calculating the RF value from that. At that point, hopefully, it's been 30 minutes have happened, and you're ready to take your aspirin out of the oven. Because remember, that was like put it in the oven, and then we did this TLC plate thing. So let's say you're not done with the TLC plate, but it's been 30 minutes. Go get it. Okay, pause what you're doing and go get it. You need to take it out of the oven, and we've got gloves that you can use because the glassware is going to be hot. Set it down, let it cool to room temperature. Once it's cooled to room temperature, you're going to go over to the balance. Place it on the balance, record the mass. Okay. Now, what we're going to do is called drying to constant mass. And that's making sure that it's actually all the way dry. Like, yeah, sure, it was in the oven for 30 minutes, but for all I know, it's still mostly filled with liquid. So to check to see if it's all the way dry, after you measure the mass, you're going to take it and put it back in the oven. You're going to leave it in the oven for another 5 minutes. So it was in the oven for 30 minutes, and now we're putting it in for 5 minutes, taking it out, cooling it, putting it on the balance to measure the mass the second time. So there's an equation on page 121 in the procedure about how to calculate the percent change between the mass the first time and the mass the second time. So you're going to take your two numbers and follow that procedure. And what we need is for it to be 1% or less. So if the difference between an extra 5 minutes of drying changed the mass by less than 1%, it was dry. Okay. If it changed the mass by more than 1%, you need to put it back in the oven for another 5 minutes to do a third weighing, take it out, cool it, put it on the balance, and measure the mass. So there are spots in your lab for 3 mass measurements from the oven. You have to do the first 2. You will only do the third one if you don't meet the 1% rule on that. Okay. Once you've either done it twice and met the 1% or done it the third time, okay, you're going to record your numbers. You're going to take a little bit of the solid that would have been on your weigh paper or your watch glass. And the thing we haven't done yet is the color test on your product. So you're going to take your scupula, you're going to take a 6th test tube. We've used a lot of test tubes. Take a few crystals, drop it in the test tube, add some water, and then add 1 drop of phenol or FeCl3. Swirl it up, vortex it, mix it with a glass stir rod, whatever, and then note what color it changed. And then you're going to record that. So at that point, we've done all 3 things. We did our color test, which we did at the beginning and then finished at the end. We did our TLC, which we're doing while the product, the aspirin, is drying, and we made our aspirin. Okay, so we got all of them accomplished. It was just kind of in the order in which it took. So at the end of the lab, nothing goes down the drain. I know it's aspirin. So number 1, you can't take it home. I don't care if it's like aspirin, I can buy that. I don't know that you made aspirin. Let's even say both tests make it look like you made aspirin. Still not good enough for you to like take it home and eat it or something. I don't care if you want to become a pharmacist. You still can't take the aspirin home, okay? So the aspirin has to stay. There's going to be a place for you to scrape all of your solid aspirin into. There's going to be a place for you to put the filtrate, which will be, the filtrate is, where are we? Oh, the stuff from the filter flask. The stuff at the bottom when you filtered it. That's got a location to go into. It's the non-halogenated waste container. The liquid that's left over at the bottom of your TLC developing chamber also goes into the non-halogenated waste container. Your test tubes that have the colors that you did the FeCl3, they have their own waste container. There's an iron waste container where those go into. But so there's the iron waste container, and then there's pretty much the everything else. Nope, I lied. Iron waste container, aspirin, like the solid waste container, and then an everything else waste container. Nothing goes down the drain, but everything goes into one of those 3 waste containers. At the end of the lab, in the broken glass box, you need to put your TLC plate and your micro pipettes. The filter paper just goes in the trash can. The rest of the glassware just needs to be washed and put back. Oh, I lied. The other thing is the filter paper with the aspirin on it, that will go in the same container as the solid aspirin because there's going to be solid all over it. Okay, so this piece of filter paper didn't have anything on it other than the liquid that was in there, and it's going to probably be dried by then. So that goes in the trash can. So we've got solid and solid filter paper, iron, and everything else waste containers. Then we've got our broken glass things, our TLC plates and our micropipettes. And everything else gets washed and put away. The test tubes are going to have a designated container for them to go to. Otherwise, you should be all good. Don't forget to read the safety data sheets and complete the safety questions for this. You're not allowed to do the lab unless you've done that. Watch the other video for the background theory and calculations for this lab.